Internet Protocol television is a system through which television services are delivered using the Internet Protocol suite over a packet-switched network such as a LAN of the Internet, instead of being delivered through traditional terrestrial, satellite signal, and cable television formats. Unlike downloaded media, Iptv offers the ability to stream the media in smaller batches, directly from the source. As a result, a client media player can begin playing the data before the entire file has been transmitted. This is known as streaming media. Iptv services may be classified into three main groups: live television, with or without interactivity related to the current TV show; time-shifted television, catch-up TV, start-over TV; video on demand, browse a catalog of videos, not related to TV programming. Iptv is distinguished from Internet television by its ongoing standardization process and preferential deployment scenarios in subscriber-based telecommunications networks with high-speed access channels into end-user premises via set-top boxes or other customer premises equipment. Definition. Historically, many different definitions of Iptv have appeared, including elementary streams over IP networks, transport streams over IP networks, and a number of proprietary systems. One official definition approved by the International Telecommunication Union Focus Group on Iptv is defined as multimedia service such as television, video, audio, text, graphics, data delivered over IP-based networks managed to provide the required level of quality of service and experience, security, interactivity, and reliability. Another more detailed definition of Iptv is the one given by Alliance for Telecommunications Industry Solutions Iptv Exploratory Group on 2005. Iptv is defined as the secure and reliable delivery to subscribers of entertainment, video, and related services. These services may include, for example, live TV, video on demand, and interactive TV. These services are delivered across an access-agnostic, packet-switched network that employs the IP protocol to transport the audio, video, and control signals. In contrast to video over the public Internet, with Iptv deployments, network security and performance are tightly managed to ensure a superior entertainment experience, resulting in a compelling business environment for content providers, advertisers, and customers alike. History. The term Iptv first appeared in 1995 with the founding of Precept Software by Judith Estrin and Bill Carrico. Precept developed an internet video product named Iptv. Iptv was a multicast backbone-compatible Windows and Unix-based application that transmitted single and multi-source audio and video traffic, ranging from low to DVD quality, using both unicast and IP multicast real-time transport protocol and real-time control protocol. The software was written primarily by Steve Kastner, Carl Auerbach, and Cha-Chi Kwan. Precept was acquired by Cisco Systems in 1998. Cisco retains the Iptv trademark. Internet radio company AudioNet started the first continuous live webcasts with content from WFAA-TV in January 1998 and KCTULP on January 10, 1998. Kingston Communications, a regional telecommunications operator in the UK, launched KIT, the brainchild of Matt Chile, an Iptv over digital subscriber line broadband interactive TV service in September 1999 after conducting various TV and video on demand trials. The operator added additional VOD service in October 2001 with YesTV, a VOD content provider. Kingston was one of the first companies in the world to introduce IPTV and IPVOD over ADSL as a commercial service. The service became the reference for various changes to UK government regulations and policy on IPTV. In 2006, the KITS service was discontinued, subscribers having declined from a peak of 10,000 to 4,000. In 1999, NBTEL was the first to commercially deploy Internet Protocol television over DSL in Canada using the Alcatel 7350 DSL AM and middleware created by Magic TV. The service was marketed under the brand Vibe Vision in New Brunswick, and later expanded into Nova Scotia in early 2000 after the formation of Alliant. Magic TV was later sold to Alcatel. In 2002, SaskTel was the second in Canada to commercially deploy Internet Protocol video over DSL, using the Lucent Stinger DSL platform. In 2005, Sirius Communications was the first North American company to offer high-definition television channels over an IPTV service. In 2003, Total Access Networks Inc. launched an IPTV service consisting of 100 free IPTV stations worldwide. In 2005, Bredbands Bolaget launched its IPTV service as the first service provider in Sweden. As of January 2009, they are not the biggest supplier any longer. Telia, who launched the service later, now has more customers. In 2007, TPG became the first internet service provider in Australia to launch IPTV, complementary to its ADSL2 Plus package. This was, and still is, free of charge to customers on eligible plans and now offers over 45 local free-to-air channels and international channels. By 2010, ENET and Telstra launched IPTV services in conjunction to internet plans but with extra fees. In 2008, PTCL launched IPTV under the brand name of PTCL Smart TV in Pakistan. This service is available in 150 major cities of the country, offering 140 live channels and more than 500 titles for VOD, with key features such as EPG, parental control, time shift television, VOD. In 2009, the company ZAAPTV came out with the IPTV receiver ZAAPTV HD1009N, a receiver that could bring live channels from all over the world. Successfully now in 2013, it is still in the market as one of the leading brands in the industry, with streaming of over 1,200 live channels. Its wide success is accredited by the strong impact it has in the United States market. In 2010, CenturyLink, after acquiring Embark and Quest, entered 5 U.S. markets with an IPTV service called Prism. This was after successful test marketing in Florida. During the 2014 Winter Olympics, shortest path bridging was used to deliver 36 IPTV HD Olympic channels. Promise. The technology was hindered by low broadband penetration and by the relatively high cost of installing wiring capable of transporting IPTV content reliably in the customer's home. However, residential IPTV was expected to grow as broadband was available to more than 200 million households worldwide in 2005. In December 2009, the FCC began looking into using set-top boxes to make TVs with cable or similar services into network video players. FCC Media Bureau Chief Bill Lake had said earlier that TV and the Internet would soon be the same, but only 75% of homes had computers, while 99% had TV. A 2009 Nielsen survey found 99% of video viewing was done on TV markets. The number of global IPTV subscribers was expected to grow from 28 million in 2009 to 83 million in 2013. Europe and Asia are the leading territories in terms of the overall number of subscribers, but in terms of service revenues, Europe and North America generate a larger share of global revenue. Due to very low average revenue per user in China and India, the fastest growing is Asia. The global IPTV market revenues are forecast to grow from $12 billion in 2009 to $38 billion in 2013. Services also launched in Bosnia and Herzegovina, Bulgaria, Pakistan, Canada, Croatia, Lithuania, Moldova, Macedonia, Montenegro, Poland, Mongolia, Romania, Serbia, Slovenia, the Netherlands, Georgia, Greece, Denmark, Finland, Estonia, Czech Republic, Slovakia, Hungary, Norway, Sweden, Iceland, Latvia, Turkey, Colombia, Chile and Uzbekistan. The United Kingdom launched IPTV early and after a slow initial growth. In February 2009, BT announced that it had reached 398,000 subscribers to its BT Vision service. Claro has launched their own IPTV service called Claro TV. This service is available in several countries in which they operate, such as Dominican Republic, El Salvador, Guatemala, Honduras, Nicaragua. IPTV is just beginning to grow in Central and Eastern Europe and Latin America, and now it is growing in South Asian countries such as Sri Lanka, Pakistan and especially India, but significant plans exist in countries such as Russia. Kazakhstan introduced its own IPTV services by the national provider Kazakh Telecom JSC in content integrator Alicast under the Iptv brand in two major cities Astana and Almaty in 2009 and is about to go nationwide starting 2010. Australian ISPEnet launched Australia's first IPTV with Fetch TV, the first IPTV service to launch on the Chinese mainland sells under the BESTV brand and is currently available in the cities of Shanghai and Harbin. In India, IPTV was launched by Airtel and the government service provider MTNL and BSNL through tie-up with AKSH and is available in most of the major cities of the country. Meanwhile, UF Group, which is the franchise owner for UFO movies in southern India, plans to offer multiple host of services such as customers' movies on demand, shopping online, video conferencing, media player, e-learning on the single IPTV set-top box branded as Imagine. In Sri Lanka, IPTV was launched by Sri Lanka Telecom in 2008 under the brand name of PEO TV. This service is available in whole country. In Pakistan, IPTV was launched by PTCL in 2008 under the brand name of PTCL Smart TV. This service is available in 150 major cities of the country. In Malaysia, various companies have attempted to launch IPTV services since 2005. Failed PAYTV provider MITV attempted to use an IPTV over UHF service but the service failed to take off. HYPP TV was supposed to use an IPTV-based system, but not True IPTV as it does not provide a set-top box and requires users to view channels using a computer. True IPTV providers available in the country at the moment are Fine TV and DETV. In Q2 2010, Telekom Malaysia launched IPTV services through the fiber-to-the-home product Unify in select areas. In April 2010, Astro began testing IPTV services on Time.com Berhad's high-speed fiber-to-the-home optical fiber network. In December 2010, Astro began trials with customers in high-rise condominium buildings around the Monte Chiara area. In April 2011, Astro commercially launched its IPTV services under the tagline, "The one and only line you'll ever need," a triple-play offering in conjunction with Time.com that provides all the Astro programming via IPTV, together with voice telephone services and broadband internet access, all through the same fiber optic connection into the customer's home. In Turkey, TTNET launched IPTV services under the name Iptv in 2010. It was available in pilot areas in the cities of Istanbul, Izmir and Ankara. As of 2011, IPTV service is launched as a large-scale commercial service and widely available across the country under the trademark TV. Super Online plans to provide IPTV under the different name WEBTV in 2011. Turk Telekom started building the fiber optic substructure for IPTV in late 2007. For hospitality, besides targeting the homes, vendors target IPTV services to the hospitality sector. IPTV is a natural progression from the pay-per-view and video-on-demand offerings. Some players such as Guest Tech, Locatel, Select TV, VDA, and Tivus have started offering IPTV to the hotels before moving into the homes. In 2005, Guest Tech launched its OneView Media platform, providing IPTV to guest rooms in hotels, where users could watch IPVOD and IPTV from ASTBSB connected to the TV. In 2013, Locatel Company launched the most comprehensively integrated IPTV platform available into new markets in Australia, Philippines, Malaysia, Thailand, Ethiopia and Sri Lanka. Architecture. Elements TV head-end, where live TV channels are encoded, encrypted and delivered in the form of IP multicast streams. VOD platform, where on-demand video assets are stored and served when a user makes a request in the form of IP unicast stream. Interactive portal, allows the user to navigate within the different IPTV services, such as the VOD catalog. Delivery network, the packet-switched network that carries IP packets. Home TV gateway, the piece of equipment at the user's home that terminates the access link from the delivery network. User's set-top box, the piece of equipment at the user's home that decodes and decrypts TV and VOD content and displays it on the TV screen. Architecture of a video server network. Depending on the network architecture of the service provider, there are two main types of video server architecture that can be considered for IPTV deployment: centralized and distributed. The centralized architecture model is a relatively simple and easy to manage solution. For example, as all contents are stored in centralized servers, it does not require a comprehensive content distribution system. Centralized architecture is generally good for a network that provides relatively small VOD service deployment, has adequate core and edge bandwidth and has an efficient content delivery network. Distributed architecture is just as scalable as the centralized model. However, it has bandwidth usage advantages and inherent system management features that are essential for managing a larger server network. Operators who plan to deploy a relatively large system should therefore consider implementing a distributed architecture model right from the start. Distributed architecture requires intelligent and sophisticated content distribution technologies to augment effective delivery of multimedia contents over service providers' network. home networks. In many cases, the residential gateway that provides connectivity with the Internet access network is not located close to the IPTV set-top box. This scenario becomes very common as service providers start to offer service packages with multiple set-top boxes per subscriber. Networking technologies that take advantage of existing home wiring or of wireless hardware have become common solutions for this problem. Although fragmentation in the wired home networking market has limited somewhat the growth in this market, in December 2008, ITUT adopted Recommendation GHN, which is a next-generation home networking standard that specifies a common PHY MAC that can operate over any home wiring. During 2012, IEC will adopt a pre-norm for POF networking at gigabit speed. This pre-standard will specify a PHY that operates at an adaptable bitrate between 100 Mbit per second and 1 Gbit per second depending on the link power budget. Groups such as the Multimedia over Coax Alliance, Home Plug Powerline Alliance, Home Phone Line Networking Alliance, and Quasar Alliance each advocate their own technologies. IMS architecture. There is a growing standardization effort on the use of the 3GPP-IP multimedia subsystem as an architecture for supporting IPTV services in carriers' networks. Both ITUT and ETSI are working on so-called IMS-based IPTV standards. Carriers will be able to offer both voice and IPTV services over the same core infrastructure, and the implementation of services combining conventional TV services with telephony features will become straightforward. The Multi-Service Forum recently conducted interoperability of IMS-based IPTV solutions during its GMI event in 2008. Protocols. IPTV covers both live TV as well as stored video on demand (VOD). Playback requires a broadband device connected to either a fixed or wireless IP network in the form of either a standalone personal computer or limited embedded OS device such as a smartphone, touchscreen tablet, game console, connected TV or set-top box. Video compression is provided by either AH263 or H264 derived codec. Audio is compressed via AMDCT-based codec and then encapsulated in either an MPEG transport stream or RTP packets or flash video packets for live or VOD streaming. IP multicasting allows for live data to be sent to multiple receivers using a single multicast group address. H.264 MPEG-4 AVC is commonly used for Internet streaming over higher bitrate standards such as H.261 and H.263, which were more designed for ISDN video conferencing. H.262 MPEG-1/2 is generally not used as the bandwidth required would quite easily saturate a network, which is why they are only used in single-link, broadcast-to-storage applications. In standards-based IPTV systems, the primary underlying protocols used are service provider-based streaming, IGMP for subscribing to a live multicast stream and for changing from one live multicast stream to another. IP multicast operates within LANs and across WANs also. IP multicast is usually routed in the network core by protocol-independent multicast. Setting up correct distribution of multicast streams from the source all the way to the customers who wants to view them. Duplicating received packets as needed. On-demand content users a negotiated unicast connection. Real-time transport protocol over user datagram protocol of the low overhead H.222 transport stream over transmission control protocol are generally the preferred methods of encapsulation. Web-based unicast only live and VOD streaming. Adobe Flash Player prefers RTMP over TCP with setup setup and control via either AMF or XML or JSON transactions. Apple iOS uses HLS adaptive bitrate streaming over HTTP with setup and control via an embedded M3U playlist file. Microsoft Silverlight uses smooth streaming over HTTP. Web-based multicast live and unicast VOD streaming. The Internet Engineering Task Force recommends RTP over UDP or TCP transports with setup and control using RTSP over TCP. Connected TVs, game consoles, set-top boxes and network personal video recorders. Local network content uses UPnPAV for unicast via HTTP over TCP or for multicast live RTP over UDP. Web-based content is provided through either inline web plugins or a television broadcast-based application that uses a middleware language such as MHEG5 that triggers an event such as loading an inline web browser using an Adobe Flash Player plugin. A telecommunications company IPTV service is usually delivered over an investment-heavy walled garden network. Local IPTV is used by businesses for audio-visual AV distribution on the company networks is typically based on a mixture of conventional TV reception equipment and IPTV encoders. IPTV gateways that take broadcast MPEG channels and IP wrap them to create multicast streams. Via satellite. Although IPTV and conventional satellite TV distribution have been seen as complementary technologies, they are likely to be increasingly used together in hybrid IPTV networks that deliver the highest levels of performance and reliability. IPTV is largely neutral to the transmission medium, and IP traffic is already routinely carried by satellite for Internet backbone trunking and corporate VSAT networks. The use of satellite to carry IP is fundamental to overcoming the greatest shortcoming of IPTV over terrestrial cables: the speed, bandwidth of the connection, as well as availability. The copper twisted pair cabling that forms the last mile of the telephone and broadband network in many countries is not able to provide a sizable proportion of the population with an IPTV service that matches even existing terrestrial or satellite digital TV distribution. For a competitive multi-channel TV service, a connection speed of 20 Mbit per second is likely to be required, but unavailable to most potential customers. The increasing popularity of high-definition television increases connection speed requirements, or limits IPTV service quality and connection eligibility even further. However, satellites are capable of delivering in excess of 100 Gbit per second via multi-spot beam technologies, making satellite a clear emerging technology for implementing IPTV networks. Satellite distribution can be included in an IPTV network architecture in several ways. The simplest to implement is an IPTV direct-to-home architecture, in which hybrid DVB broadband set-top boxes in subscriber homes integrate satellite and IP reception to give near-infinite bandwidth with return channel capabilities. In such a system, many live TV channels may be multicast via satellite with stored video on-demand transmission via the broadband connection. Archiva's Satellite Media Solutions division suggests IPTV works best in a hybrid format. For example, you would use broadband to receive some content and satellite to receive other, such as live channels. Hybrid IPTV. Hybrid IPTV refers to the combination of traditional broadcast TV services and video delivered over either managed IP networks of the public Internet, It is an increasing trend in both the consumer and pay TV markets. Hybrid IPTV has grown in popularity in recent years as a result of two major drivers. Since the emergence of online video aggregation sites like YouTube and Vimeo in the mid-2000s, traditional pay TV operators have come under increasing pressure to provide the subscribers with a means of viewing internet-based video on the televisions. At the same time, specialist IP-based operators have looked for ways to offer analog and digital terrestrial services to their operations, without adding either additional cost or complexity to their transmission operations. Bandwidth is a valuable asset for operators, so many have looked for alternative ways to deliver these new services without investing in additional network infrastructures. A hybrid set-top allows content from a range of sources, including terrestrial broadcast, satellite, and cable, to be brought together with video delivered over the internet via an Ethernet connection on the device. This enables television viewers to access a greater variety of content on the TV sets without the need for a separate box for each service. Hybrid IPTV set-top boxes also enable users to access a range of advanced interactive services, such as VOD, catch-up TV, as well as internet applications, including video telephony, surveillance, gaming, shopping, e-government accessed via a television set. From a pay TV operator's perspective, a hybrid IPTV set-top box gives them greater long-term flexibility by enabling them to deploy new services and applications as and when consumers require, most often without the need to upgrade equipment or for a technician to visit and reconfigure or swap out the device. This reduces the cost of launching new services, increases speed to market and limits disruption for consumers. The Hybrid Broadcast Broadband TV Consortium of industry companies is currently promoting and establishing an open European standard for hybrid set-top boxes for the reception of broadcast and broadband digital TV and multimedia applications with a single user interface. These trends led to the development of hybrid broadcast broadband TV set-top boxes that included both a broadcast tuner and an internet connection, usually an Ethernet port. The first commercially available hybrid IPTV set-top box was developed by Advanced Digital Broadcast, a developer of digital television hardware and software, in 2005. The platform was developed for Spanish pay TV operator Telefónica, and used as part of its Movistar TV service, launched to subscribers at the end of 2005. An alternative approach is the IPTV version of the head-end in the Sky Cable TV solution. Here, multiple TV channels are distributed via satellite to the ISP or IPTV provider's point of presence for IP-encapsulated distribution to individual subscribers as required by each subscriber. This can provide a huge selection of channels to subscribers without overburdening internet trunking to the POP, and enables an IPTV service to be offered to smaller remote operators outside the reach of terrestrial high-speed broadband connection. An example is a network combining fiber and satellite distribution via ANSES New Skies satellite of 95 channels to Latin America and the Caribbean, operated by IPTV Americas. While the future development of IPTV probably lies with a number of coexisting architectures and implementations, it is clear that broadcasting of high-bandwidth applications such as IPTV is accomplished more efficiently and cost-effectively using satellite, and it is predicted that the majority of global IPTV growth will be fueled by hybrid networks.